Okay, we want to know which set represents the intersection of sets A, B, and C, as shown in the diagram below. So the intersection of all three is actually, if you look at the way they constructed this, we have A right here, and A is this circle, right? So that's one of our sets. And B is right here, right? This is our set B, the red circle. And C will be our green circle, let's say, right here. And the intersection is literally in the Venn diagram where the three all overlap, and that's right here, right? So there's only one area where A, B, and C all overlap. Now, you might notice these little numbers in here. These are the elements in each set. So let's go through this for a moment. We're saying in A, right? A would be the numbers 1, 2, 3, 4, and 7. All the numbers that are literally somewhere inside the circle A. And you could write that down, right? We could write, okay, so A, use purple, and I'll write it over here. A is equal to 1, the elements 1, 2, 3, 4, and 7. Okay, so we've got those elements there. What does B equal? Well, B is equal to 2, 3, 5, 6, and 8. Right? B is equal to 2, 3, 5, 6, and 8. And C, and bear with me here, I want you to be really comfortable with this, is all the numbers that are somewhere inside the green circle. So that's 2, 4, right? 5, 6, 7, and 9. Okay, so an intersection would be elements that are actually in all three, and the only one that does that is 2. It's the only number that are in all three. These other areas around that intersection, right, like this area for 4 and 7, if you think about what this yellow area is that I'm coloring in, that's the intersection of only A and C. So what numbers are only in both A and C? Well, 2, 4, and 7 are the intersection of A and C because those numbers are in both A and C. But 4 and 7 are the only numbers that are in the intersection of A and C, right? So that'd be the intersection of A and C and not B. Over here, right, you have the intersection of what? Oops, pick a different color. Well, here you'd have the intersection, I'll use an orange, of B and C, and not what? Well, not A, right? Just 5 and 6 are in B and C, but 5 and 6 are not in A. So it's the intersection of just B and C. Going around, we have, let's pick one more light blue. Here, the number 3 is what? Well, if you look around, 3 is in B and 3 is in A, but not in C. So 3 is the intersection of A and B and not C. 2 and 3 are the intersection of A and B, but 2 is also in C. So depending on how you look at this, there are different ways to define the numbers. This area over here, that's not in any intersection, is the area represented by, let me just pick a different color, the area that represents numbers, that are just in A. So the number 1 is just in A and nothing else. And that's true. 1 is only in A. B over here, the number 8, is the only number. 8 is the only number in B, and just B. And 9 is the only number that's just in C. So that's this area over here. So there's a lot to look at in these Venn diagrams. Here the answer is just 2. They want the intersection. It looks like choice 4 is the union, which is every element that's in A or B or C. But we want the intersection here. And again, the symbol for intersection, in case you see it, you would see this. You would see A intersect B intersect C. And it would be that notation right there. All right, hope this helped.